When odd number of inputs are high, output is high. When odd number of inputs are high, output is high. Now make a truth table. What is the meaning of a truth table? The table that, what is the meaning of truth table? How do you define a truth table? A table of all possible inputs. Truth table means it's a table of all possible inputs. Can you make a truth table of a 3-input XOR gate? Truth table for a 3-input XOR gate. Maybe you can give a name ABC. Output. Truth table of a 3-input XOR gate. Always truth table should be in an ordered form. 0, 0, 0, 0, 1, 0, 0, 1, like that, ordered form. So it should be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. Then 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1. Where do you have odd number of inputs as 1? Rest all zeros. So this is the proper definition of an XOR gate. You should remember. I see a lot of people have different definitions, maybe made it up by themselves. That's all not correct. Rest all you can do, NOR, NAND, NOR, right? I don't think you need me. And there's something called XNOR, right? What is XNOR? Just opposite of this. Don't use the word even. Opposite of this. Okay. What will be the truth table for that? Wherever you have 0 here, you will have 1 there. Okay. So I think I don't want to waste much time on things that you already know. There's something called Boolean algebra. I'm not going to bore you with that because you all know it. But some basic stuff that might help you. When you say A bar plus A, the plus means OR gate. When you write a Boolean expression, what is the meaning of plus? OR gate. So if you, what is the meaning of this? You are trying to say something like this. When you have A here, you put a NOT gate here. What is the output for this?
1.
It is 1. Why? If you say A equal to 0, 0 will become 1 here. So you'll get 1. If you say A equal to 1, this is 1 is enough to say 1. So always this output is 1. Anything plus its bar will be equal to 1. Kind of important. You just have to remember it for anyhow, for anything. I mean, 1 plus A. And then 1 dot A. Some basic Boolean expression, Boolean algebra that you should remember. Nothing difficult, but the first thing I say that we are going to use it again and again and again. That's necessary. What else? I think this much is sufficient. What is the meaning of this dot? How do you express XOR?
A bar plus A bar B.
No, I'm not talking about Boolean expression. There is some symbolic representation, something like this. Something. A. Right. It's plus, no, not dot and dot.
Dot for XNOR.
Okay. Okay, then this is about Boolean algebra, basic AND gate logic gates. Now, what can we do? What can we do? How do you reduce a Boolean expression? How do you no. K-map? How does a K-map work? Something like that. No. For example, for a two variable K map, how does it look like? Four cells. Okay. Let us say A and B are the variables. Then what is this one? This. So this is 0, 1. Okay. How about a three variable K map? Let us say A, B, C, A, and this will be.
B bar C,
Okay. Fine. And how about a three variable K map? Sorry, four variable. And we should be giving this thing 0, 1, and how about here? A, B, C, D. Well, how do you say this? A bar, here A bar B, A B, and how do you number them? What color? 0, contrast. 1, 2, 3, 5, 7, 8. Ah. Here's the five variable. What do you do? Say we started, for people who came late, we started with simple logic gates. All you know, nothing new. But one thing special, you should understand XOR properly. What is the meaning of XOR gate? Odd number of inputs are high, output is high. I have seen just this definition only asked in lots of ISRO and some state government exams questions. What is the meaning of XOR gate? Odd number of, this is one of the options. The other options are inputs are same, output is high, inputs are not same, output is high. So something like that. So that's all not true. This is the proper definition. And the second is, what is a truth table? How does it look like? What is the meaning of a truth table? Meaning of a truth table is all possible inputs, and particularly in the ordered fashion. In the ordered fashion, not just random. Truth table should be always in an ordered fashion. Why do you say that it should be in ordered fashion? Only then you can use K-map easily. So you want to use K-map, no? So how does the K-map for this one look like? Can you tell me? Say this is a three variable K-map. So where all do you have ones? What is the, how does the K-map for this one look like? XOR gate K-map. You will have one here, one here, one here, one here. There is no possibility of combinations. So this is a XOR gate K-map. You will see a lots of questions. Just this K-map will be there. The moment you see this, you should be able to recognize it is an XOR gate. Yeah, it will save a lot of time. We are in no hurry. We are just going to do this in this session and make sure that you understand this. 2 to 4 mark questions they will ask. How do they ask questions? I have seen most of the questions will be based on reducing Boolean expression. Some will be based on some simple adder subtractor circuit, but that's a little bit, that is also they ask. It's also important. And some questions based on multiplexes. 3 types of questions. Boolean algebra, the first thing is very, very important. A plus A bar is always 1. B plus B bar is always 1. C plus C bar is always 1. Okay, so that is something we are going to use a lot, again and again and again. How do you combine them? How does the combination work? There is yeah. See, for example, you have a situation like this. Uh, how do we? What color can I use? I use this color and like this. How do we combine this? Can I combine like this cross? This is okay. So, and even if you plan to do horizontal, can I do something like this? No. So, what is the rule? 2. If you should look for maximum possibility, 8, 4, 2. So, maybe the proper way is this. Now that you have combined this, what is the term associated with this combination? What are the literals you should be writing? A, C. Why A and C? These are the common terms. A and C. Okay. And can I combine like this? Can I use this repeatedly? Like this? Okay. If you combine this, what is the final answer? It will be
AB plus BC
A. Okay.
AB
The final answer should be AB.
plus AC
Okay. AC.
BC.
Common terms in these two cells is B, A. So that's how we got AB. Okay. That's how we got that. Spend some time. If you are new to it, maybe I will stop here for a few minutes. What is the meaning of K-map combinations? Actually, if you don't combine, if you write the terms separately, what will be the equation? Boolean expression. Yeah. What is it? From the K-map, can you write Boolean expression? That is the question. From the K-map, what is the Boolean expression? Something like that. See, from the K-map, what is the Boolean expression? What is this? If it is 1 here, it is A, B bar C plus what is this one? A, B, C. And what is this one? A, B, C bar. Okay. B, C. Now say I give you this expression and I ask you to reduce this expression. What is the technique you will use? Say, forget K-map. In the question, I give you this expression and I ask you to reduce. What is the technique you use? Yeah, what are the for example, in these two things, what are the common terms? AC. And what is left? What is this one? That's what I'm trying to say. And then, so the final expression will be AC plus AB, C bar plus A bar, BC. But this is not equal to this, no? So that means through expression, we can only go all the way this much. We cannot go further. You understand? This is the final reduced expression. But we have not come there through our techniques. I'm going to stop here for a few minutes. I'm trying to explain what is that K-map, what is the benefit that K-map offers. K-map is reducing better than our Boolean expression reduction technique. What is the benefit K-map offers? Now, I can wait. So okay, a small value addition. If I say A or B, A or B, that means there is a OR gate between them, A or B. If I say there is one more input pin and I connect it to A, will it change the result? Can I, the question I'm trying to ask, can I add one more, I mean, XOR gate A? Will it change the result? Already A is there in the equation. Now I'm going to OR with A again. Will it change anything? Otherwise, I will extend this thing. There is a XOR gate. If I connect A in both the terms, what is the output? Sir? A. So that means you can have any number of A's here. The final answer will be, in other words, I can have any number of A's here. The final answer will be still be A, just A or B. That means you can have these terms as redundant as many terms you possible. So why do I say that? Say I have an expression here. No, can I ABC again? No problem. No, same thing. That's what I said sometime back. Any term you can redundantly add any number of terms. I mean redundantly or any number of times. It does not change anything. Now in these two, I took some common. Between these two, what are the common terms? AB. So plus between these two. So finally, I ended up getting this expression. So the idea, now question is, how do I know that I should add this only again and again? That comes from K-map. This is ABC term. That is recombined 3 times. So that is why. Listen. So what does a K-map does? K-map gives you a pictorial representation of a Boolean expression. It is a pictorial representation of Boolean expression. All it does is when you try to combine them, you're doing this B plus B bar so that it vanishes. So that's what I did here. You see, ABC, I kind of did again and again and again. And then I took common terms and then I ended up with a similar expression. So how does a K-map work? What does K-map do? It gives you an idea about which term need to be redundantly ORed so that you end up getting a reduced Boolean expression. Redundantly ORed. That means again and again you're doing it. Redundance. So what is the trick here? A plus B or A or B, you have some expression like that, you can OR A again and again, it will not change the expression. All right, only this much. I think it's time to solve some problems. You should be choosing some tricky questions. Okay. See, they have a K-map like this. What color shall I use? Red. This is some one. X. What is the meaning of this X? Don't care. What is the meaning of don't care? Don't care means it is either 0 or 1. It's up to the user to choose. So you can choose it as 0 or 1. Now, how do you reduce this? This is the given K map. Try to reduce it. Don't care means it is either 1 or 0. It is up to the user to choose 1 or 0. Okay, so how does it go? You can do this, and then what else? 4 corners. So the best possibility is this, and this is the answer. And then you write common terms. How do you write common terms? By the way, what is the common term for all these corners? For all these corners, I see D bar is common. What else? And also B bar is common. And how about for these 4 cells? B bar is common. What else? C bar. Common terms. What are the common terms in all these 4 cells? What are the common terms? So can you help him? Choose some questions and solve them. ஏதாவது question choose பண்ணீங்களே solve. Choose some questions and solve. See, not this book, only one book is there. Share from. Not that, sir. That's different book. That's what book? Friends, any question paper you take, there is a definite question on Boolean expression came up. For 1 or 2 mark, கண்டிப்பா கேட்போம். அதெல்லாம் question paper இல்லை. So 100% it is coming. How it is coming, I want you to go through the question bank. Sir, you can go and ask for easy electrical question bank on போய் கேட்டுவாங்க. எடுத்துட்டு வந்திருக்கேன், இவர் எடுத்துட்டு வந்திருக்காரு. See, if you anybody wants any question bank, please go and request them. If they are giving, you can take. Okay. Okay, while you are solving, I say for example, if this K map is given, we grouped once, we got a Boolean expression. Is this the only way of getting a Boolean expression? There is another type of Boolean expression where you group zeros. How do we do that? Maybe I want to solve that question. Same thing. Now I want you to group zeros. Then what do you do? What is the Boolean expression? How do you write a Boolean expression after grouping zeros? After grouping zeros, how do you group? Now I want you to group zeros and then write a Boolean expression. See here, now we are going to group zeros. How do you group zeros? Say these two cells you group. In the previous case, we said output equal to so and so. When you group once, output equal to. When you group zeros, output bar equal to. That is the important change. Whenever you group zeros, output bar equal to whatever you get. So what do you get in these two common terms? A bar, B bar. The same thing, that the same way you write. And these two cells, what are the common terms? B bar, C bar. And in these two, A bar. Now, this is output bar equal to. What is output equal to then? You have to take the whole bar on the other side. But how do you take this bar inside? There is a law for that. What is that law? What is the definition of that law? Yeah, can you make it a statement as an English statement? Okay, that is all correct. But as a bookish statement in a book, how do they say? They say negate every literal and interchange and or gates. Make a note. De Morgan's law means negate every literal, and interchange and or gates. Negate every literal, interchange and or gates. Interchange and or gates. And or and. Negate every literal, interchange and or gates. So that's what I'm going to do now. Negate every literal, interchange and or gates. What is the meaning of literal? See, each term is called a literal. So you take this bar inside, I'm going to negate it. It's going to look like this. Output equals A bar, B bar, the whole bar. Interchange and or gates. Negate every literal, interchange and or gates. Again do it. A double bar is A. Here dot is there, so plus it will become plus. So there are two ways of getting a Boolean expression from a K-map. There are two ways to get a Boolean expression from a K-map. One is by grouping ones, and the other is by grouping zeros. Either way is correct. But one thing is, when you group zeros, you end up getting what is called product of sum. That means when you group ones, you would have got just make good notes. Even if you have lost touch, slowly you will get it. There is nothing great about this subject. See, one thing I have seen people doing as a mistake. They see this one, and then they think that if you want PYS, just to say A plus C into B, A plus B into B plus C. That's not correct. Accidentally, for this problem, it happens to be same. It is very accidental. It just happens once. In most cases, it is not true. You have to follow the proper methodology. What is the proper methodology? When you group zeros, you say output bar equal to the same way. Take the bar inside, De Morgan's, follow the rules. See, this has got nothing to do with this problem. See, what if they say, can you solve this question? A SOP form is given, POS form is asked. SOP given, POS asked. SOP given, POS asked. SOP given, POS asked. How will you solve this question? SOP given, POS asked. Not a randomly made up question. It's lots of gate questions similarly have appeared. I want you to go through the question bank. You will find out SOP given, POS asked. Very rarely they give POS and ask SOP. You should be able to do that also. There are two types of Boolean expression, SOP form and POS form. One form given, other form asked. It is a usual gate question. There are two types, only two types, not more types. There are only two types of gate question. Sorry, two types of Boolean expression. SOP form, POF form. One form given, other form asked is a usual type of gate question you should be able to solve. How will you do it? As you keep staring this question, I just want to point out that I've given you this expression and I am asking you this expression. How will you solve? I think you have the answer already on board. What is the method you will develop? My suggestion is from here, go to K-map. From K-map, you can do it. How do you go from here to a K-map? That's the most tricky part. How to go from here to K-map? In other words, I'm asking, can you draw a K-map for this one? Do it. First observation, how many variables are there? 3 variables. Check if you have, everybody gets 3 variables. Get, okay, thank you. Can you make a K-map from a Boolean expression? From a K-map, you made a Boolean expression. Good. Can you do the reverse? Can you make a K-map from a Boolean expression? That skill is a necessary skill you have to learn now. Making a K-map from a Boolean expression. Maybe you can even write it, that how to make a K-map from a Boolean expression. Okay. AB. Where is AB, sir? Common. Where is A means what? What is the meaning of A? Which row is it? Second row. And where is B? A, B means A is common here, B is common here. So the intersecting cells are these two cells, A, B. How about BC? Next is AC. A is common here, C is common here. How to make a K-map from a Boolean expression? From this, what do you do? Remaining places you substitute and then group zeros. Since we are interested in POS form, you should group zeros. So what are the skills we have discussed? First is, how does a K-map work? What is the magic it does in reducing Boolean expression? It tells you which term is redundantly need to be odd so that you can reduce it using the technique of A plus A bar is 1. Second, there are 2 ways to get a Boolean expression from a K-map, grouping ones and grouping zeros. Can you make a K-map from a Boolean expression? A very necessary skill. Now go through the questions. I want you to choose some tricky questions and then solve. Choose this opportunity in the classroom. Choose tough questions. I've tried to give you all the necessary information to get 2 marks. Morning session, 1 or 2 mark. Now at least 4 marks we should complete. What question will you choose, sir? The first question பாருங்க. First question என்ன கொடுத்திருக்காங்க? SOP கொடுத்திருக்காங்களா? POS கேட்டிருக்காங்க. Don't write anything on the book, friends. These are for sale, so don't write. இதுல இருக்கு பாருங்க. One more thing. I'd like to add one more thing. If we say this output positions of ones is represented by summation symbol. Positions of ones, or in other words, they call it min terms is represented by the symbol summation symbol. Where do I have ones? This is 3, 4, 5, 6, 7. So 3, 5, 6, 7. Next, what are the positions of zeros? Whatever is not there here. But what is the symbolic representation for that? Pi. Max terms, they say max terms. This is called min terms. This is called max terms. 0, 1, 2, 4. So you can write this K map like this also. See, when I see the question, they say F equal to, what is the question? F equal to A bar, D bar. What is the meaning of this? In other words, when you're trying to say summation of, the position of 1 is in 0. What is the next term?
A bar, B, C bar.
What is the meaning of this?
0,
What is the next term?
A, B, C bar.
1, 1.
A, B bar, C.
So from the Boolean expression, see, I got positions of ones. From the Boolean expression, I got positions of ones. Why didn't I do that here? Why didn't I do that here? Because this is a reduced expression. From a reduced expression, you cannot directly get positions of ones like this. So I need to go here and then get here. If it is not reduced, then I can directly go from here to here. In this question, they have given you an expression which is not in a reduced form. So I can go directly from here to here. And even the solutions are not reduced. Every term, all the terms are there. They have not reduced any solution. So there is no need to use K-map at all here. I want to point out in this question, there is no need for K-map. Once you know positions of zeros, what are the positions of ones? Whatever is not there. What is it? 1, 3, 5, 6, 7. Now, whenever you are using positions of zeros, you put F bar equal to 1 means what? 0, 0, 1. 3 means uh, then 5 means
A, B bar, C.
6 means
6, A, B, C bar.
now this is F bar equal to no. Take the bar inside, see which option matches. That is the correct answer. One case we used K-map. In one case, there is no need for K-map. Because question and the options both are in a non-reduced form. There's no reduction happening. So there's no need for K-map. K-map is a tool to reduce the Boolean expression. Take the bar inside, then what will happen? Tell me which option matches it. So when you take the bar on the other side, what are the terms you will have? A plus B plus C bar. Then A plus B bar C bar. A plus B bar plus C bar. So if you have not got this option, kindly check with the neighbors, discuss, make sure you understand it. சார் இவங்க பூலியன் எக்ஸ்பிரஷன் ரெடியூஸ் பண்ணல சார். கே மேப் எதுக்கு? 3 டேர்ம் இதுல இன்னும் காமன் இருக்கு, அதெல்லாம் எடுத்து பண்ணாதானே பூலியன். அவங்க கொஷின்லயே பாருங்களேன், அவங்க மேலேயே ரெடியூஸ் பண்ணிருக்கலாம். ஏ பார் சி பார் காமன் எடுத்து ரெடியூஸ் பண்ணிருக்கலாம்ல, அவன் பண்ணவே இல்லை. அவன் என்ன பண்றான்னா, ரெடியூஸே பண்ணாத ஒரு பூலியன் எக்ஸ்பிரஷனை எஸ்ஓபில இருந்து பிஓஎஸ் மாத்துங்கன்றான். ரெடியூஸ் பண்றதுக்கு தானே கே மேப். 3 டேர்ம் அப்படியே இருக்கு பாருங்க. அது 2 டேர்மாவோ ஒரு டேர்ம் ஏ மட்டும் இருந்தது இல்ல ஏபி மட்டும் இருந்ததுன்னா ரெடியூஸ் பண்ணியிருக்கான்னு அர்த்தம். 3 டேர்ம் அப்படியே இருக்குன்னா ரெடியூஸே பண்ணலன்னு. அதனால கே மேப்பே தேவையில்லை. ஏன்னா நேராவே டேர்ம் வந்துச்சு பாருங்க, 0 இருக்கு, 2 இருக்கு, 4 இருக்கு. ப்ரீவியஸ் கேஸ் நம்மளால சொல்ல முடியல. ஏபி பிளஸ் பிசி பிளஸ் சிஏன்னு இருக்கு. அங்க எனக்கு 0 0 0 வந்தது 0 டேர்ம். Choose some other question, friends. Different questions you choose. Sir, if POS is given, SOP எப்படி சார் கொடுப்பீங்க? மேடம் ஒன் क्वेश्चन இருக்கா பண்ணுங்க. ஃபர்ஸ்ட் அப்சர்வேஷன் பிஓஎஸ்னாலே இட் ஷுட் ரெப்ரசென்ட் ஜீரோஸ் தானே. நீங்க என்ன பண்ணுங்க, ரெண்டு பக்கமும் பார் போட்டுருங்க. பிஓஎஸ்ல ரெண்டு பக்கமும் பார் போட்டுருங்க. எஃப் பார் ஈக்குவல் டு அப்படின்னு ஒரு எக்ஸ்பிரஷன் வருமா, அந்த பார் உள்ள போயிட்டீங்கன்னா இந்த பக்கம் எஸ்ஓபி வந்துருமா. அப்போ இது வந்து பொசிஷன்ஸ் ஆஃப் ஜீரோஸ் வந்துருமா. அப்படியே கீழே இருந்து மேல போங்க, ரிவர்ஸ்ல அப்படியே கீழே இருந்து மேல போங்க, ஒன் ஸ்டெப். அப்படியே ரிவர்ஸா போகும். So what is important is hereafter you should go through your notes and find out what is the usual mistake you are doing. இன்னைக்கு என்ன தப்பு பண்றீங்களோ அதே தப்பு example இருக்கு. அதனால ஒரு நோட் தனியா ஒரு A4 sheet எடுத்து வச்சு I made a mistake in solving K-map question so and so mistake அப்படின்னு எழுதி அது அப்படியே ஞாபகம் எக்ஸாம்பிள் அந்த சிச்சுவேஷன் வரும்போது இதுதான் கான்ஷியஸ் நீங்க என்ன தப்பு பண்றீங்களோ நிறைய students இந்த பண்ண தப்பு நீங்க ரிப்பீட் மிஸ்டேக்ஸ் நீங்க நோட் எழுதுறது ரிப்பீட் நீங்க இந்த தப்பு பண்றீங்க நினைச்சிருக்கீங்க அதெல்லாம் அதே தப்பு தான். Can you help me? Madam, choose your department questions. Choose any question. I'm just suggesting you that some questions will be like வெறும் English statements are equation expression இருக்காது. You should get used to that. ரொம்ப எக்ஸ்பிரஷனா அந்த மாதிரி ஏதாவது இருக்கும். நம்ம ஈக்குவேஷன் அப்படி இருக்கும். சம்டைம்ஸ் ஒன்லி இங்கிலீஷ் ஸ்டேட்மெண்ட்ஸ், நிறைய பிக் கொஷின்ஸ். சார் G15Q1 பாருங்க எப்படி இருக்குன்னு. G15Q1 சால்வ் பண்ணுங்க. ஆஃப்டர் தட் நெக்ஸ்ட் கொஸ்டின். G17Q2. Oh, set. Already it is a reduced Boolean expression. இன்னும் ரெடியூஸ் பண்ண முடியுமான்னு கேக்குறாங்க. Boolean expression reductionனாலே நமக்கு தெரிஞ்ச ஒரே டூல் என்ன? K-map போட்டிங்களா? கொஸ்டினுக்கு ஒரு K-map போடுங்க. எப்படி இருக்கு? ஓகே, வெரி குட் சார். பிசினா இங்க வரும்ல, இங்க ஒன்று வரணும்ல. பிசி இல்ல, பிசி இஸ் sir, what is the question number? G17Q2. ஃபர்ஸ்ட் கொஸ்டினுக்கு ஒரு K-map போடுங்க. ஆப்ஷன் ஏக்கு ஒரு K-map போடுங்க. ஆப்ஷன் பிக்கு ஒரு K-map போடுங்க. Go on. எல்லா ஆப்ஷனுக்கும் K-map போடுங்க. எந்த K-map எக்ஸாக்ட்டா மேட்ச் ஆகுதோ அதான் ஆன்சர். You don't have to reduce at all. You understand what I mean? You can make a K-map for the question. You can make a K-map for the options. Whichever K-map exactly matches, that is the answer. Reduction ல இருந்தே தப்பிச்சிடலாம். ஏன் ரிடக்ஷன்ல ப்ராப்ளம் இருக்குன்னா, each one will reduce his own way. புரியுதுல? அவங்க எதிர்பார்க்குற மாதிரி உங்களால் ரெடியூஸ் பண்ண முடியாது. But we all know that a reduced Boolean expression will have exact K-map of the question. Make a K-map for the question. Sir, if possible, every question you can do it. But most of the cases, you don't have to do it. K-map போய் தான் நீங்க சால்வ் பண்ணணும்னு அவசியம் இருக்காது. But as you see, some questions where there is no reduction happening, அந்த K-map தேவையில்லை. ரிடக்ஷனே இல்லாம ஒரு கொஸ்டின் பண்ணல ஃபர்ஸ்ட் ஒரு கொஸ்டின், அதுல ரிடக்ஷனே இல்லை, மூணு டேர்ம் அப்படியே இருந்தது. அப்போ K-map தேவையில்லை. எங்கெங்கெல்லாம் ரெடியூஸ் பண்ணிட்டாங்களோ அப்போ K-map போயிட்டா தான் ஈஸி. Whenever you are trying to reduce it, K-map is the easiest way to do it. Output is and of ஏன் ரெண்டு அண்டு வருதுன்னு தெரியுதுல்ல. அப்புறம் A, B ஓகே இல்ல இது. இப்போ இதே அங்க பாருங்க, கொஸ்டின் நம்பர் என்ன, G15 Q1. அவங்க என்ன சொல்றாங்கன்னா இந்த அண்டு கேட் மட்டும் அண்டு கேட் கிடையாது, இது அண்டு கேட் கிடையாது, AB plus CA, AB plus BC plus CA, இது மட்டும். சார் அந்த கொஸ்டின் ஒன் ஆஃப் த டஃபஸ்ட் கொஸ்டின் அந்த வருஷ கொஸ்டின் பேப்பர்லயே, டிஜிட்டல்லேயே அந்த கஷ்டமான கொஸ்டின். இன்னும் சொல்லணும் அந்த மொத்த சப்ஜெக்ட்லயே அது கொஞ்சம் கஷ்டமான கொஸ்டின். வெரி ஃபியூ பீப்புள் அட்டெம்ப்டட் இட். ஏன் இந்த மாதிரி ஒரு சுச்சுவேஷனை இங்கிலீஷ்ல எழுதிட்டாங்க. அதனால see, now this is something, if you give ABC, it produces an output. What is the output they are saying? Boolean expression is AB plus மறுபடியும் இதை கொண்டு போய் இங்க இதே மாதிரி இன்னொன்னு, அதுக்கு ஒரு ஃபைனல் அவுட்புட் என்னன்னு கேக்குறேன். One of the input is this. I think there is a NOT gate no here. So ஒரு NOT gate கூட போட்டாங்க இங்க. ஓகே இல்ல, இதுக்கு என்ன பண்ணிருக்காங்க அதே மாதிரி, இதுக்கு AB C bar, இங்க இதுதான் சிச்சுவேஷன். இங்க என்ன, இங்க வந்து ABC கொடுத்தா இந்த எக்ஸ்பிரஷன் வரும், இங்க AB C bar கொடுத்தா இங்க என்ன எக்ஸ்பிரஷன் வரும்? வெரி குட். அவன் என்ன எக்ஸ்பிரஷனா இருக்கும்? AB B C bar. இந்த எக்ஸ்பிரஷன் இங்க என்னவா மாறி இருக்கும்? ஹோல் காம்ப்ளிமெண்ட் வாட் எவர் இட் இஸ். சி இங்க என்னவா இருக்கும்? இது A, இது B, இது C. ரொம்ப கஷ்டமா இருக்குல்ல? இதுக்கு நான் ஒரு வழி சொல்லிட்டேன், இன்னொரு வழி இருக்குது சால்வ் பண்றது. மொத்தமா என்னென்ன வேரியபிள்ஸ் இருக்கீங்க, எத்தனை வேரியபிள் இருக்கு? அனலாக்ல தான் இன்புட் வந்து all possible infinite possibilities are there. ஒரு 0 to 1 volt குள்ள you can have infinite voltages. Digital best என்ன, all possibilities are known. For 3 input how many possibilities are there? 8 possibilities. என்னென்ன possibilities? என்னென்ன possibilities? You know it. இப்போ இங்க for example 000 கொடுத்தா, இங்க 000 கொடுத்தா இந்த எக்ஸ்பிரஷன் என்ன சொல்லுது? இங்க 1 ஆயிடும். இங்க என்ன ஆகும்? 001 கொடுத்தா இந்த எக்ஸ்பிரஷன் என்ன சொல்லுது? 0 0 110 கொடுத்தா இந்த இதே இந்த எக்ஸ்பிரஷன் என்ன ஆகும்? இங்க சரி இது என்ன, இது இதே தான் சார். இங்க என்ன இன்புட்? இப்போ ஃபார் எக்ஸாம்பிள் இது XYZ ன்னு வைங்க, இது என்ன கொடுக்கும்? இங்க XY YZ ZX. புரியுதுல? இது என்னது? இதே எக்ஸ்பிரஷன் தான். என்ன வரும்? சரி இங்க 1 சார், இங்க 0 அப்படின்னா 0 தான். ஸோ இதை வச்சுட்டு நான் இந்த ட்ரூத் டேபிள் ஃபில்அப் பண்ணிடுவேன்னா இதுதான் ஆன்சரு. Boolean expression reduction is also equal to truth table way. இதுதான் நம்ம கொஸ்டின் ஆன்சர் கேட்டிருக்காங்க. ஆப்ஷன்ஸ் என்ன கேட்டிருக்காங்க? இட் இஸ் a 3 input. அப்படின்னு இதை ஃபில் பண்ணிட்டு இது என்ன கேட்டுன்னு சொல்லுங்க. அதான் ஆன்சர். I am trying to use the situation that it is after all a 3 input set circuit. 3 input na 2 power 3 8 possibilities தான் இருக்கு. எல்லா பாசிபிலிட்டிஸும் நான் இன்புட் பிளக் இன் பண்ணி நான் நார்மலா பூலியன் எக்ஸ்பிரஷன் சால்வ் பண்ணாலே எனக்கு அந்த 2 நிமிஷம் கூட ஆகும். First you should be able to draw this. Then you plug in A, B, C values each and every time, 8 possibilities, and then get the output. Okay? Take your time. This is the maximum difficult question that can appear in a combinational circuit. In 2015 கேட்டாங்க. இதுக்கு அப்புறம் இந்த மாதிரி ஒண்ணும் கேட்கல. I just want to take this opportunity to solve this. I just wanted to draw the relationship. அதாவது இது என்னன்னா, it is a circuit where 3 variables are the input, 1 variable is the output. So after all, அந்த total circuit உடைய output. நான் எல்லா பாசிபிள் இன்புட்டும் கொடுத்து பார்த்துட்டு எனக்கு என்ன வருதுன்னு பார்க்கறேன். Okay, spend some time. Maybe I will try to put it in a different way. First என்னோட சஜஷன் என்னன்னா, what is the truth table for this one? அதை பண்ணிடுங்க முதல்ல. இதுக்கு என்ன ட்ரூத் டேபிள்? இது நம்ம காலையில இருந்து போட்டுட்டே இருக்க, திரும்ப வரும். கேரி 0 1 1 நான் இதுக்கு ட்ரூத் டேபிள் என்ன? கேரி சார் இது. இதுக்கு சொல்றேன் நான். இதான் இதனுடைய ட்ரூத் டேபிள். சொல்யூஷன். Wait. You are jumping. Sir, first this is the truth table for this. Agreed? இது ஓகே சார். இந்த பூலியன் எக்ஸ்பிரஷன் இதுதான் ட்ரூத் டேபிள். AB plus BC plus CA சார். நம்ம எதுவும் பண்ணல. இதுதானே வருது. என்னென்ன வருது? 3 5 6 7. அதான் பண்ணியிருக்கேன். 3 5 6 7. Sir, this is the truth table for this one. We did in the morning. 3 5 6 7. திருப்பி பாருங்க, காலையில் இதே எக்ஸ்பிரஷன் தான் POS SOP மாத்தி SOP POS மாத்தி. We played around this expression many times. This is the carry of a full adder. That is why we will talk about it. First you should get a truth table for this Boolean expression. Okay இல்ல? இப்போ 0 0 0 கொடுத்தா இங்க 0 வருது. இதை வச்சு நான் சொல்றேன். அடுத்து அதே மாதிரி இங்க 0 0 இதுல சப்ஸ்டிட்யூட் பண்ணணும் ஒவ்வொரு வாட்டியும். ஓகே, இதுக்கு வேணா ட்ரூத் டேபிள் பண்ணுங்க. இதுக்கு எதுக்கு ட்ரூத் டேபிள்? இதை வச்சே பண்ணிட வேண்டியது தானே. 0 0 0 0 0 1 1 0 0. Every time you can substitute also, no problem. Okay. இந்த மாதிரி ஜெனரலா அசியூம் பண்றல, நமக்கு தெரிஞ்சு இதுல மொத்தமே 8 பாசிபிலிட்டிஸ் தான் இருக்கு. அந்த 8 பாசிபிலிட்டியை நம்ம அசியூம் பண்றோம்னு சொல்றேன். என்னென்ன 8 பாசிபிலிட்டிஸ்? 0 0 0 0 0 1 0 1 0. அது எல்லாத்தையும் அசியூம் பண்ணி நீங்க டேபிள் கொண்டு வந்தீங்கன்னா அதான் ஆன்சர். If you are smart you can do it. For example, first row பண்ணோம், அவுட்புட் 0 வந்துருச்சு. அதை வச்சு என்னென்ன கேட் இல்லைன்னு சொல்லிடலாம். NAND கிடையாது, NOR கிடையாது, 2 3 ஆப்ஷன் போயிடுச்சுல. அடுத்து வேற என்ன ரோ நீங்களே சொல்லுங்க. ஸ்மார்ட், வெரி குட், கரெக்ட். அடுத்து என்ன ரோ நீங்க சூஸ் பண்ணலாம் சொல்லுங்க. இப்போ நான் ஃபர்ஸ்ட் ரோ பண்ணேன். ஃபர்ஸ்ட் ரோ பண்ண உடனே எனக்கு இங்க என்ன வந்துச்சு? 0 வந்துச்சு. நாண்டுக்கும் நாருக்கும் கண்டிப்பா இங்க 1 தான் வந்திருக்கணும். ஸோ அதை வச்சுட்டு நாண்டு கிடையாது, நார் கிடையாது. வேற என்னென்ன ஆப்ஷன்ஸ் இருக்கு? Time for combination circuits. What is a half adder? Two inputs are there, A, B. Output is sum and carry. Well done. For example, if you add 1 plus 1, this is not OR gate, this is addition. When you add 1 plus 1, answer is 2. 2 means, how do you represent 2 in the, what is this one called? Carry. And this one is called sum. So you have A, B as the inputs, carry and sum as the outputs. 0, 0, all possible inputs. Fill it up. This is half adder. If you have 3 inputs, that is called a full adder. Full adder means it has 3 inputs, A, B, C. Output is, so you have 1 plus 1 plus 1, 1, 1. Get the truth table. Rendu truth table pannunga. This is half adder, half full adder. Next I want you to do half subtractor, full subtractor. That's all. These truth tables are necessary. I have seen some questions directly they have asked what is the truth table, so you should definitely know. Half adder, full adder, half subtractor, full subtractor. The nalume it is compulsory you should know. Next we will talk about multiplexers. Tomorrow morning we'll have this flip-flops, okay, flip-flops and all the sequential circuits. Later in the after the noon we will talk about ADC, DAC. We have chosen tough questions, okay, in the class. At least rest of the questions you have to solve. It's your duty. Class is only 50%. Your efforts is 50%. Most of the people who answer good here, who solve all the questions here, they don't go back solve at home. They will not even qualify. Class is just to the starting. You have to go back and work. Every day morning, you see this tea shop. டீ கடைக்காரன் காலைல 3 மணிக்கு எந்திரிக்கிறான் சார். ஒரு மாசம் எந்திரிங்க போதும், நல்ல ரேங்க் வரும். எஜுகேஷன் இஸ் ஈஸி வே ஆஃப் லிவிங். ஒரு மாசம் வேலை செஞ்சீங்கன்னா போதும், லைஃப் லாங் வேலை செய்ய வேண்டியது. 1 or 2 months you put effort. Morning 3:30, 4 o'clock every day you wake up 6-7 hours you put effort. You get decent rank. Carry on. The moment you wake up, get up from the bed, leave the bed. That is a tough part. You should do it. Not 2 months you have to do it. The moment you wake up, leave the bed. Go wash your face, start working. In school days, people will tell. At this age, they will not tell. So they are not doing it. So what is the behavior? Make a note. Sum, whether it is full adder or half adder, sum is always XOR gate. Sum is always a XOR gate. Whether it is full adder or half adder, sum is always a XOR gate. 0. Next, full adder, 3 input, ABC 3 input. Sum is a XOR gate and carry is AB plus BC plus CA. Sum is a XOR gate for 3 input, that is full adder. For full adder, sum is a 3 input XOR gate and carry is AB plus BC plus CA. Next is half subtractor. Next is half subtractor and full subtractor. Half subtractor, full subtractor. What is 0 minus 1? Minus 1. If you express minus 1 in 3-bit, how does it look like? Table 3 complements. Complements. 3-bit table. Minus 1, 2's complement formula எப்படி இருக்கு? 1 1 2-bit formula சொல்லணும்னா எப்படி சொல்வீங்க? MSB neglect பண்ணிடுவீங்க. So the answer is 1. Minus 1 is 1 1. இதை எப்படி இன்னொரு விதமா எப்படி புரிஞ்சிக்கலாம்னா, இதை சப்ராக்ட் பண்றதுக்கு பாரோ கண்டிப்பா அவசியம். There is a difference between 2 bits. So difference is yes. Yes னா 1. அப்படியும் புரிஞ்சிக்கலாம். So now from 1 1 if you subtract 1, what is the answer? From 1 1 if you subtract 1, the answer is 1 0. 1 1 ல இருந்து 1 subtract பண்ணா 1 0. So that is for full subtractor. Yeah, I'm just telling you. So make a truth table here. Again, I want you to observe that difference is always a XOR gate. Make a note. Difference, whether it is full adder, full subtractor, half subtractor, difference is always XOR gate. Difference is always difference and sum are always XOR gate. Subtractor la difference nu solluvom, inga sum nu solluvom. 1 minus 1 is 0 then sir. 0 0.
1 minus 1.
Sir, 1 1 minus 1. Half subtractor, full subtractor. So in the B confuse ஆயிட மாட்டீங்க. Borrow difference in எழுதணும். Sir, this is borrow. This is different. என்ன சார் இது சார் 0 - 1 இதை சப்ராக்ட் பண்றதுக்கு பாரோ தேவையில்லை. எனக்கு கீழே இருக்கிற நம்பர் பெருசு, மேல இருக்கிற நம்பர் சின்னது. பாரோ தேவையா? அப்போ 1 போடுங்க. இது ரெண்டுத்துக்கும் நடுவில், இந்த ரெண்டு பிட்டுக்கு நடுவில் டிஃபரன்ஸ் இருக்கா? 1 டிஃபரன்ஸ் இருக்குல்ல, தேர் நாட் சேம் பிட்ஸ், அப்போ 1. அதனால அந்த வேர்டே பாருங்களேன், டிஃபரன்ஸ் பிட்வீன் 2 bits. Do you need to borrow to subtract? Yes na 1. Full subtractors have 3 variables, a minus b minus c. This is half subtractor. How will you do with full subtractor? Correct, sir. So check if this is correct. What pass point? All right. See, One last topic, multiplexer, then we'll stop. Sir, what is 0 minus 1 minus 1? What is the final answer? Minus 2 then. Minus 2 க்கு 3 bitல என்ன சொல்றாங்க? 2's complement form. ஒன் ஒன் அது 3 பிட்ல 2 பிட்ல கேட்டா அதான் உங்களுக்கு வந்திருக்கு. சப்ராக்ஷன்ல 0 minus 1 minus 1 1 0 வந்திருக்கா பாருங்க. Boolean expression, sir. What is the Boolean expression? Multiplexer. Multiplexer give Boolean. Multiplexer, how does it work? Okay. If I give 0 0 at the select lines, if I give 0 0 at the select lines, S1 க்கும் S0 க்கும் 0 0 கொடுக்கறேன்னு வைங்க, அவுட்புட் என்னவா இருக்கும்? I0 கனெக்ட் ஆயிடுமா? 0 1 கொடுத்தா இப்போ இந்த பூலியன் எக்ஸ்பிரஷன் எழுத சொன்னா எப்படி எழுதுவீங்க? கரெக்ட். எப்படி எழுதுவீங்க? ரெண்டுமே 0 கொடுத்தா அவுட்புட் என்ன வருது? அடுத்து 0 1க்கு well done. Then see if you understand this. இதுதான் சார் கஷ்டம். இந்த பூலியன் எக்ஸ்பிரஷன் புரியுதா பாருங்க. இதே ட்ரூத் டேபிள் எப்படி எழுதுவீங்க? இன்புட் வந்து இது இன்புட் இல்லையா, இது அவுட்புட். 0 0 கொடுத்தா அவுட்புட் என்ன? 0 1 கொடுத்தா 1 0 கொடுத்தா இது எழுத தெரிஞ்சுட்டா which question shall I solve? G15. How about this? Okay. G15. What is the question, sir? Okay. So what is it they have said? They have given you the truth table, no? A, B, C, D. F. Positions of zeros சொல்லிட்டாங்க. 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So they say there is a 0 here, there is a 0 here, அப்புறம் there is a 0 here, there is a 0 here. மீதி எல்லாம் 1. This is given in the question. So now they say that these are the select lines A, B, C. So 0 0 0, maybe I will use different color. So what we see, they want you to draw the relationship between, when you give, I'm going to draw the truth table for, multiplexer. If you give 0 0 0, output is I naught. Seems like that I'm trying to draw the relationship between D and F. When D is 0, we know that when you give 0 0, I naught will be connected. When D is 0, F is 1. When D is 1, F is 0. So I would say that at the place of I naught, let me connect a D bar. Why? When D is 0, I'll get 1. When D is 1, I'll get 0. How about the next case? Irrespective of D, I need 1. So I will not care about D at all. I'll just connect 1. Go on, fill it up. That is the answer. I'm trying to draw the relationship or the dependence of F on D. F को D को என்ன ரிலேஷன் பார்க்குறேன், அதை வச்சுட்டு அந்த பின் ஒவ்வொரு வாட்டியும் கனெக்ட் பண்றேன். ஏன்? When ABC is 0, there are two possibilities based on D, and there are two outputs. So I'm trying to draw the relation between F and D. If f does not depend on d, I'll just give whatever value. Either it is 1 or 0, I'll connect that. If f depends on d, then I try to connect that pin there. Spend 5 minutes, you will understand. It's not tricky part. It's the same thing, the other question also. I'll do the other question also on board, don't worry. Fill this up. What will be, how about the I2 pin? Here it is. Here it will be. So what is the relation between this and this? Inverse. How about this one? Irrespective of this, I get. If I need, whenever you give 0, 1, 1 to the select lines, I3 will be connected. Whenever you give 0, 1, 1, I3 will be connected. I just want 1 here. அப்போ connect on I3 ல நான் 1 connect பண்ணிடுவேன்ல. Whenever you give 0, 1, 1, I3 will be connected to the output. I just want 1. So I will give here 1. See, I just want 1. So I gave here 1. Irrespective of the D value. Should I use D or not? That's all. Some cases D will be useful, some cases it is unnecessary.